back. This is A-Level Computer Science 9618 Paper 3 and this is Chapter 2, which is Communication and Internet Technologies. So in this topic, we're going to understand that whenever we try to send a message or a file or anything like that, anything, either a text or message or file or anything from sender to receivers, then how do these messages, these data are go from sender to receiver? What kind of a rules, what kind of a protocol that we try to follow? Okay, so that's what we're going to understand in this topic. So whenever we try to send a message, that message will be broken down into in a form of packets, and those packets will go through in a layer, on these 5 layers: application layer, transport layer, network layer, data link layer, physical layer, and then come to the receiver. Okay, so it follows a protocol. What is the protocols is known as a set of rules that must be agreed between a sender and a receiver. Okay, so that's what a protocol means, and we follow a protocol suite, which is TCP/IP protocol suite. Okay, whenever we try to send a message or sending a file or anything, sending any kind of data from one computer to another computer, from one mobile phone to another mobile phone. Okay, so they are in a form of number of packets, and these packets go through these 5 layers: the application layer, transport layer, network layer, data link layer, physical layer, and then come to here, and then again go through these layers from bottom to top to come to the receiver. Okay, so what does it contain? It contains these 5 layers. So it's a suite of communication protocol used to interconnect network devices on the internet. Each layer adds its own header to the packet. So again, whenever we try to send a message, it broke it down into packets, and these packets are header. Each time these packets go through a layer, the layer add a header into these packets, and then keep on going, and header keep on they are being attached every time they pass through these layers, one after the another. Okay, so yeah, each layer adds its own header to the packet. Each layer contains different protocols and handles a different part of the transmission. The output from one layer provides the input for the next layer. Output becomes an input for the next layer. Now output from one layer provides okay. I mean, like for example, the message is an input. It comes here, and then the output of this layer provides the input of this layer, and then it provides the input of this layer, and then this layer and this layer, and then it goes through here, and it keeps on going. Okay, now let's discuss about the 5 layers. Application layer. What is the application layer? Application layer contains all the programs that exchange data, such as web browser or server software. And in application layer are some protocols that we can use, and each protocol contains a port, a number that identifies that which protocol are being used. So each port can be assigned to the different protocol in the application layer. It tells to the transport layer to something called the port, so that TCP knows where the data is coming from. Okay, protocols. HTTP. It is responsible for correct transfer of files that make up web pages on the World Wide Web. FTP is for sending files between computers, from one computer to another. Whenever we try to send any kind of file or message, we use FTP. Okay, and there are some form of FTP. Anonymous FTP is when you are accessing a file without any need to identify yourself. Like for example, if you are accessing a site, you don't need to give your password or to show your identity. You can just access the files. So you can say the website is completely open, it's public for anyone to access the files. Okay, so anonymous access allowed. File FTP commands are those which we can make an action to change those files which are stored in the FTP server. And yeah, then we got POP3, which is a protocol for receiving the emails, also known as pull protocol. When emails are downloaded by the client, they are then deleted. That's the disadvantage in the POP3. They are deleted from the server, which means it is not further updated. Every time a client downloads the email, that email will then they are deleted. So another form of protocols, alternative of POP3 is IMAP, which is Internet Message Access Protocol. It handles the receiving of emails, the same things. The only difference is only a copy of the email is downloaded, which means those emails are not deleted. And so I think it's much more preferred to use this if you want to know your past emails. Okay. SMTP is when sending your emails. Simple mail transfer protocol. This handles the sending of emails, text-based only. Sometimes if you are purely using this, but if you want to send some media files, so you need to put a MIME header into that transmission. MIME header. Use at the beginning of the transmission. Client uses this header to select which media player is needed when the attachment is opened. Okay, so these are the protocols for the application layer. Now we come to the transport layer, and the application layer okay, so yeah, um, so you're sending a data, you're sending a message, and you just choose any one of these protocols, then you put a header into that packet. Okay, and then packet will go to the transport layer, and inside the transport layer will add another packet, and that packet will become known as segment. Down into into packets, and they are known as segments. So order and assembles data packet for transmission across the network. The TCP resides in this layer. The TCP comes into this transport layer. Okay, it checks packet port to identify the application layer, that which protocol is being used by checking the application port. Okay, now what does the TCP do? It divides the data into proper size chunk, which are packets, and then passed on to the network. So TCP is the one that divides the data into proper packets. Okay, it converts the whole message into a form of packet, small size packet. In order to pass them onto the network, it waits for the acknowledgement of sent packets and set timeout to resend the packet if acknowledgement are not received in time, which means it tries its best to make sure that if it is sending the packets, so it tries to wait for the acknowledgement that yes, the packet are received and safe and sound. It checks incoming packet sequence number to ensure data is reassembled in correct order. Establish an end-to-end connection between the two host computer using handshakes, host-to-host transmission protocols, and yeah. So that's what TCP does. When sending packets, it tries to wait for the acknowledgement, and when acknowledgement is received, it makes a green tick that yes, it's done. Let's go to the next layer. Now inside the network layer, the packets are known as datagrams. It handles the movement of data on the network. It determines the address of the destination computer and works out a route for the packets to be sent across the network. The IP protocol is used in here. The main protocol used at this layer is IP. Okay, takes the packet received from transport layer and adds a further header. Like all the other layers does this, they always add a header whenever the message or packet goes through that layer. It adds a further header. This header contains the IP address. Sounds familiar for you guys, right? We have discussed in P1, computer science P1. The IP address identifies the computer on the network, public IP, private IP, etc. So this header contains the IP address of both the sender and the receiver. Then it goes straight to the data link layer, which is another layer, and the packets are known as frames in this layer. It makes sure that there is error-free transmission and determine the flow rate. And MAC address also assigned MAC address to each packet of the sender and receiver. The MAC address is in the NIC of your computer. With the help of NIC, data link layer provide a means to transfer data from one to another via local media, coaxial, fiber optic, copper wire. Actually, this means we are talking about the physical layer that will come, but for now, let's move on. A switch works in this layer because each end system is connected to the switch by a full duplex link, so no collision is possible along that link, which means those wires are connected to the switch, and switch makes sure that no collision become possible. Use packet switching to handle data. Use packet switching, we will come to that later, to handle data transfer. Routers are also used. Routing routers operate on this layer. They are used to connect the network together. Okay, physical layer, where you are determining how physical connection are to the network are set up. You are doing through a wire, optic fiber, radio waves. How will you try to send the bits physical way in one form to another? How bits are represented into particle signals as they are transmitted either electricity, optically, or through radio waves. So let's summarize all of this. First, we got the application layer. The application layer, through the application layer we are sending a message. We are using a protocol, any one of these protocols. After selecting those any one of the protocols and sending the message, the messages are broken down into small size chunks, which we can call it segments. Okay, TCP does the work. It also makes an acknowledgement. It makes sure that everything's all the packets are sent, and also it waits for the acknowledgement as well. Okay, and also make sure that they are assembled in correct order. Then we have the network layer, where we assign the IP address of the sender and the receiver, and make sure handles the movement of data, and determine the address of the destination computer, and works out a route for the packet to be sent across the network. Then we got the data link layer, where we have the MAC address. We assign the MAC address, and we also make sure that there's error-free transmission, and switch and routers are work in this layer, where we have so many routers and they are connected to one another like a spite, like a web. Okay, packets are going through these, packet switching. In order to summarize all of this, packet switching is used in this layer. Okay, use packet switching to handle data transfer. We will understand what is packet switching. Then we got the physical layer finally, where we try to make decision that what kind of physical layer which we should choose to send the data or bits. Either it is in optical fiber, radio waves, or coaxial cable, anything like that. So these are the 5 layers that a message must go through in order to reach its destination. So after going through this, then again the packets have to again go through this from bottom to top to reach the receiver. Okay, so this is TCP/IP protocol. And now let's understand about packet switching, the circuit switching and packet switching. Okay, so what is a circuit switching? Let's start with this. It's use a dedicated channel circuit which lasts throughout the connection, like making a telephone. When you are talking to someone, you first of all try to make you establish a connection between a sender and a receiver, like talking to someone on a phone or on a telephone network. Okay, that's where circuit switching is used, because you are using only one dedicated line. The circuit use is dedicated to the single transmission only. Data transfer rate is faster than with packet switching. A packet of data cannot get lost, since all packets are in sequence and along the same single route. So they are single route and they are in sequence form, and the packets of data cannot be lost. So real time streaming can be used for circuit switching. The drawback is if there is a failure fault on the dedicated line, there is no alternative way, which means you will have to wait in order for the line to be established, because there's only one route. Dedicated channel required greater bandwidth. It consumes greater bandwidth. The time required to establish a link can be very long. Okay, the application obviously which I have told you: telephone networks, private telephone network, private data networks. Okay, mostly telephone networks. Now we come to packet switching. That was circuit switching. We were just establishing a single line between a sender and a receiver, and you are making a connection, and you are doing telephone networks. Packet switching is when you are sending packets into message. You are sending a message, and that message is broken down into so many packets, and it is going through routers to router in order, and then finally reaching its destination. It also chooses the most shortest path. So message is broken down into a number of packets. The packet will need to assemble at the end in the correct order at the destination. Each packet flows its own path. The shortest path available is selected. So what are the benefits? It's possible to overcome failed or faulty lines. It's not like circuit switching that we have only one line. In packet switching, there are so many possible ways to go through. Okay, rerouting packages, which means you have routers connected to one another. They are connected to one another and another, and until you just reach the destination, sender, receiver, the packets are going through here, and then they try to find out the shortest path to come to the receiver. The packets go through routers to routers. Okay, the routers which helps to make the whole network. So easy to expand traffic usage, high data transmission possible with packet switching, no need to tie up a communication line, it's not like a circuit switching. The drawback is if a packet is lost, the sender has to resend, which means it's time consuming. The channel has to share its bandwidth with other packets as well, but because there are so many senders, the packets are going through, number of packets are going on this on this web read by routers. Okay, so the communication are shared by other sender. The channel has to share its bandwidth with other packets. Yeah, which means there are so many packets are going through these channels. Okay, so many number of packets does not work well with real-time data string because there's a possibility that that packet could be lost. What are the application? Data communication, transmitting digital data directly to its destination, which is the internet. Packet switching is used on the internet. Like for example, you're texting someone or doing a message, anything like that, anything that you do in a network. You're online, you're talking to someone. This is where data packet switching is used. That message is broken down into packets, and packets go through routers and then reach its destination. Function of a router in packet switching. Routing tables contain the information to forward a routing tables contains the information to forward a package along the shortest path route to allow to reach its destination. Packet header is examined, and packet header contains so many things like IP address, MAC address, port numbers, and it contains so many things. Okay, packet header is examined and compared with the routing table. The table supplies the router with instruction to send the packet to the next available router. So the routing table determines which router will be best option for the packet to go. Okay, send the packet to the next available router. And there you go, this is packet switching, circuit switching. Then we have BitTorrent protocol. So it's a protocol that we might have heard. You guys might have heard this, and some of you may have used this for downloading illegal contents, illegal copyright stuff like movies or any kind of anything. Okay, so it's an internet transfer protocol. It's a peer-to-peer network. We as a peer, we try to help one another. We try to share our resource to one another. We are one big empire. Okay, we are helping to one another. There's no no client, or there's no one to look after us. Like there's no teacher to look after its student. The students are just connected to one another. Okay, so there's no structure, no controlling mechanism. There's no structure. We are free to do whatever we wanted, but we have to follow some rules. Peers act as both clients and server. They're called a seat because they are acting as client, they are receiving it, and they're acting as a server, they are giving it as well. Allow, okay, only those which are only those which are receiving and sending, they are known as a seed. If they're only receiving it and not sending anything, they are known as leeches. They're only downloading stuff, but they are not giving anything. Okay, allows fast sharing of files. Leechers are those who only download the stuff, they don't give anything back. Very, very bad thing. Every content provider should create a file named Torrent. Is a file that contains the name of a tracker, and the tracker is a server that maintains a list of all the other peers which contains those content. A server that leads peer to the content. So Torrent is a file that contains the name of the tracker, and the tracker is a server that maintains a list of all the other peers on only those peers which contains the small portion or even a big portion of that of that file, of that content that we wanted. It will tell us that okay, so this peer have this, okay, I will connect to this, like that. A server that leads peer to the content. So a list of the chunk that make up the contents. Yeah. Peers who wish to download the file must obtain the torrent in order to get the pieces of the file and connect to appropriate tracker. Peers connected to the tracker will know where to find the piece of the file they need. Swarm is a group of peers connected together. It's a swarm, a group of peers. Once a peer has downloaded a file completely or requires a piece of the file and makes it available to other peers, they become a seed. They become a helping hand people. A peer is required to can remain online so they can become part of the seeding process, become part of the movement. A lurker is a peer that downloads many files but does not make any new available content, are known as the lurker. And this is BitTorrent, my friend, ladies and gentlemen, and thank you so much for watching. I hope I'll see you guys in the next video, and in the next video we'll discuss about chapter 3. Thank you so much.